ऐसे recordings मिल जाएंगे and then you can have some doubt classes, ठीक है, for the half yearly examination. But we are going to go through the syllabus and try to complete the syllabus rather than just focusing on the half yearly examination. Right, Mamuna? I think we talked about this, right? Huh?
Yeah.
Okay. So now please write a few things regarding inner transition. That is the F block elements. Inner transition elements. So inner transition elements we have two. One is lanthanides and the other one actinides. Lanthanides, yeah, lanthanoids, actinides, yeah, actinoids. लिखिएगा. What are lanthanides and or lanthanoids? These are the 14 elements following lanthanum. After lanthanum, whatever 14 elements we have, those are known as lanthanides following lanthanum. Next, actinides. What are actinides? 14 elements following actinium. ठीक है. So the lanthanides, it start from lanthanum. Lanthanum के बाद है आपके पास cerium, and from cerium to lutetium. Cerium to lutetium. ठीक है. अच्छा, by the way, what is the atomic number of cerium and lutetium? Cerium is 58 and lutetium is 71. 58 से लेके 71. These are the lanthanides. And actinides में you have starting from thorium to lawrencium. Thorium, that is 90, to lawrencium, that is Lr 103, Lr lawrencium. Please copy this down. Hopefully, जल्दी से कॉपी कर लीजिए. We're going to first of all learn about lanthanides, then we are going to learn about the actinides. तुरंत हो जाएगा, ज्यादा टाइम नहीं लगेगा. So while we will be discussing the lanthanides and the actinides, also include lanthanum and actinium in the discussion because they pretty much resemble lanthanides and actinides. The actinium, it resembles actinium. Okay? They are not parts of lanthanides and actinides, but whenever we discuss them, we are going to include the lanthanum and the actinium also. Can I move on? We have to lanthanides. First is lanthanides. Lanthanide. Lanthanide will be number one. The general electronic configuration. The general electronic configuration for the lanthanide is 6s2, 5d में 0 or 1 electron, and 4f is progressively filled from 1 to 14. Okay. The most oxidation state, most stable oxidation state, it is +3. So lanthanides are shown as Ln, and Ln +3, it has oxidation. This oxidation state, it removes the electron from 6s2, both the electrons from the 6s2. If there is any electron in the 5d orbital, that is also removed, or if not, then from the 4f14. So lanthanum 3 or lanthanide 3 positive will be having a general electronic configuration of 4f, and the f will be having 1 or 1 to 14 electrons, depending on what lanthanide we are choosing. So there are 14 elements, so uske hisab se 1 to 14. Next point is regarding atomic size and ionic size. Atomic size and ionic size. So basically, first of all, as we move through the lanthanides, there will be a decrease in the atomic size from lanthanum to lutetium due to lanthanide contraction. Lanthanide contraction पहले ही discuss हो चुका है in the D block element. So first point is gradual decrease in atomic size from lanthanum to lutetium. Okay, lanthanum to lutetium. See, we are including lanthanum also in the discussion because it only resembles, but it is not part of lanthanide. ध्यान रखिएगा इस चीज का. Due to lanthanide contraction. Okay, just to remind you guys, why does the lanthanide contraction occurs? Due to poor shielding of 4f electrons. Poor shielding of 4f electrons. Okay. Second point is regarding the ionic size. Now the decrease in the ionic size of Ln3 positive or general lanthanide, not very gradual, and it has some ups and downs here and there. So please write the decrease in size of Ln3 positive. Ln is a generic term for lanthanide. Ln3 positive is not very gradual. Next thing is regarding the oxidation state. Now, first of all, we have seen that Ln3 positive is most stable oxidation state. Second point is lanthanum 2 positive and lanthanide 4 positive also exist. Okay? Generally exist when you are having half filled, fully filled, or if you have like complete all the FL bond, in that case you are going to have 2 positive or 3 positive. जिसके examples में first of all, ठीक है, now these are very important. First of all, cerium 4 positive is possible. Cerium 4 positive is possible due to stable 4f0 configuration. Basically, cerium 4 positive जो है ना configuration. If you remember, what is the atomic number of cerium? The atomic number is 58. Now, if you are going to remove 4 electron, it will become 54, and 54 atomic number belongs to which element? Tell me guys, 54 atomic number to which element?
Xenon.
Xenon, है ना? And xenon is a noble gas, right? So when it's cerium, it is in 4 positive state, then it is quite stable because of 4f0 configuration. And third configuration. Okay, it is like inert gas. Next point is regarding uh, europium. Europium 2 positive is possible due to stable 4F7 configuration, and yttrium 2 positive is possible due to stable 4F14 configuration. Then we have TB, which has electronic configuration of 6S2 and 4F9. यहाँ भी TB4 positive is possible because that will give you from the S and 2 electrons from the 4F, it will give you 4F7 configuration, that is half filled. Then you have SM, which is having 6S2 and 4F6. Now, in this case, mm, 4F, I think it is 8. In this case, SN3 positive is very stable because of 4F7 configuration. Samarium is 62. Copy this down. I will. Then we are going to move to some general properties. So, S2, 4F. Just give me. Samarium पे इसका last वाले का छोड़ दीजिएगा जरा. Remind myself. Samarium का छोड़ दीजिए. Raise your hand if you're done writing. Waiting for Rishita. Right. Some general properties. First one. Lanthanides are generally white, silvery, soft metals. Second, most of the ions of lanthanide, most ions are colored due to presence of F electrons. Due to presence of F electrons. ठीक है. Now, certain chemical properties. So lanthanides, they show reaction, and they show reaction by using the oxidation state. ठीक है ना? By using the +3 oxidation state. देखिए reactions बहुत ही आसान है इसके. ठीक है, you don't have to worry too much about the reactions. Just remember that the +3 state of lanthanum will be there. So for example, if you have lanthanum plus O2, then it is going to give me lanthanum nahi, lanthanoids, lanthanum Ln2O3, just like Al2O3, just like Al2O3. Similarly, Ln plus sulfur is going to give you Ln2S3. Now, if you have Ln plus any halogen. So, for example, if I have chlorine, so क्या बनता है? Aluminium chloride. What is the formula of aluminium chloride? What is the formula of aluminium chloride?
AlCl3.
AlCl. Halogen will be X2, है ना? So it will make what? LnX3. Now this Ln can be anything, है ना? Europium or samarium or terbium or ytterbium, anything, any one of the lanthanides. Similarly, if I have Ln plus nitrogen, then it is going to give you Ln nitride, है ना? Lanthanum nitride. If I have Ln plus carbon, then it is going to give you LnC. Now in this case, it is showing what? It is showing the +4 oxidation state. Next is Ln plus water. It will be hydroxide, which will be of the formula LnOH whole thrice. I have lanthanides plus, let us suppose certain acid, any acid, HCl वगैरह है, it is going to liberate H2 gas. ठीक है? So all of these reactions you don't have to memorize. Just remember this. Ln has the oxidation state. Oxygen valency of oxygen is 2. Simply make the compound Ln2. Ln has 3, nitrogen has valency of 3, 3 is to 3 will be 1, so it will be Ln. Okay, copy this down. Now, fourth point is quite important regarding mixed metal. MISCHMETALL. Okay. So mixed metal. Now this particular point is important because NCERT में bold करके है लिखा हुआ mixed metal, है ना? So what is mixed metal? Please write with me. Consist of 95% of a lanthanide metal, approximately 5% of iron, and traces, that means very small amount of some non-metals such as sulfur or carbon or calcium, maybe sometimes calcium or aluminium. It is an alloy used in production of bullets, shell, and lighter flint. ठीक है, this is quite important. After that, you will write the heading actinides. So in actinides also, you are going to have general electronic configuration, which is 7s2, 6d has 0 or 1 electron, and 5f1214. Now, in this case, the 5f subshell gradually filled. Important point regarding this is that 7s, 6d, and 5f have very similar energies. Have very similar energies. ठीक है? And for energy difference between them is very low. उससे क्या होता है ना, that you will get a lot of exceptions of the off-bow principle in the actinide. Actinides में it's not necessary कि 6s में 2 ही इलेक्ट्रॉन हमेशा हो, और 5s is also always filled. In order to gain stability, you may have configuration in which the, I mean, 5f it is not filled and 6d is filled. ठीक है, इस तरह की configuration आपको मिल जाएंगी. Next you will write ionic size. Right here, gradual decrease in size of M3 positive ions due to actinoid contraction. Due to actinoid contraction. Now, actinoid contraction क्या है? Similar thing as lanthanide contraction. And antinide contraction ये क्या होता है? Due to shielding of 5f electrons. ठीक है, अगर बात की जाए which contraction is larger, जहाँ कहाँ पे effect ज्यादा होता है, then actinide contraction. Actinoid contraction is greater than lanthanide contraction. In contraction due to poorer shielding of 5f subshell. Raise your hand, one student. Waiting for Maimuna and Rushta. Next important discussion is regarding the oxidation state. ठीक है, now the first point itself is very important. Greater range of oxidation state is present due to lower energy difference between 7s 6d and 5f subshell. In general, this is important, है ना? Greater oxidation state क्यों? Because the last shell is 7, है ना? So you can remove the electrons from there also, and the energy levels of 7s and 5f is very similar. So you can remove the energy 5f also, right? Both of these are quite easy to remove because they are what very larger shells, and their energy is also what very closely related. So you can have oxidation से एक इलेक्ट्रॉन भी निकल सकता है, दो भी, तीन भी, चार भी, पांच भी, and so on. In general, कहीं पे भी सवाल आ जाए ना, like variable of why does something shows variable oxidation state, the answer you should give is always this one. Whether they ask it regarding the d block elements, whether they ask it regarding lanthanide, whether they ask it regarding the actinide, always give low energy difference due to low energy difference and whatever shell is present. Now, for example, if they are asking about the d block elements, then you can say that the ns and n minus 1d subshell, ns n minus 1d subshell, they have very different, very lower energy difference. If they are asking about actinides, then obviously you have to specify 7s, 6p, and 5f. If they ask about lanthanides, also to put, even though they do not show too much range of oxidation state, but if they ask, you will write due to lower energy difference between the what 6s, 5d, and 4f subshell for the lanthanides. याद रहेगा? Tell me guys. बोलो.
Yes, sir.
याद रहेगा? Okay. All actinides show plus 3 oxidation state except corium. Corium plus 3 नहीं दिखाता है. It shows plus oxidation state due to stable 5f0 and inner configuration. See, so actinides and lanthanides both show plus 3 oxidation state in most of the compounds. Right, next, general properties. So these are silvery gray in appearance. These are very reactive. When boiled in water, they form oxide and hydride. All actinides react with HCl to form hydrogen gas. It is a tendency of metals to react with acid and give you H2. Next point, they don't react with acids such as HNO2 due to formation of protective oxide layer. They show this is basically like a very common phenomena. Whenever HNO2, HNO2, HNO2 नहीं, HNO3 nitric acid, not nitrous. Okay. Due to formation of protective oxide layer. Now, they generally, now generally whenever oxide layer is present, further reaction, whether it is oxidation या फिर कुछ और भी चीज. For example, aluminium के example बहुत ही important है. Aluminium it does not rust very easily because whenever there is a reaction with oxygen, an oxide layer forms. अब वो oxide layer it acts as a barrier for the aluminium and the oxygen that is in the atmosphere. ठीक है. HNO3 से भी reactant से क्या बन जाता है? There is an oxide layer formed above the metal, and that oxide layer it is now acting as protective layer, and it is acting as a barrier for aluminium for the actinides and the HNO3. Okay, they show paramagnetism due to unpaired 5s electrons. लास्ट में लिखेगा आयोनाइजेशन एनर्जी ऑफ लैंथेनाइड्स, actinides कर लिखे of actinide is lower lanthanides due to greater penetration of 4f electron than 5f electron. Now the copy कीजिए, then we are going to write the comparison between actinides and lanthanides. Raise your hand once you're done writing. Waiting for Maimuna. Next, comparison between lanthanides and actinoids. फर्स्ट ऑफ पॉइंट कुछ ना सिमिलैरिटीज हम आपको बता देते हैं. फॉर एग्जांपल, अर्ली लैंथेनाइट्स early lanthanides and actinides have similar properties. ठीक है. मीनिंग, like for example, initially you have cerium, thorium, and cerium और thorium के जैसे जो elements है, they are going to have similar properties, है ना. as you have on cerium में we have +4 oxidation state, right? Cerium has +4 oxidation state, and if you go to thorium also, where did we write? Thorium shows +4 oxidation state, right? So initially the properties lanthanide and actinide, they are quite similar. Now, next point is lanthanide contraction and actinide contraction both have effects on the size and properties of succeeding elements. Okay. Last point is only regarding the lanthanide basic strength of hydroxides of lanthanoid decreases increase in atomic number. Okay. Now you write lanthanoid and like this. The general electronic configuration. So this is basically 6s2 5d में 0 to 1 and 4f has 14 electrons. Similarly, in actinide 7s2 6d is 0 to 1 and 5f 1 to 14. Okay, so this is the general electronic configuration. Secondly, lanthanides, they have mostly plus oxidation state and few cases of +2 and +4. Certain elements which shows +2 and +4. Actinides में क्या होता है, +3 तो है ही and higher oxidation state has +4 +5 +6 and even +7 तक चला जाता है. 4f electrons are tightly held by nucleus. लेकिन if I compare the 5f electron, then the 5f electrons are not as tightly held. Electrons are not as tightly held. 4f electrons have greater shield, therefore contraction is less. उतना साइज डिक्रीज नहीं करता जितना एक्टिनॉइड्स में डिक्रीज करता है, ठीक है। यू कैन राइट 5s electron have poor shielding effect, therefore contraction more. A very important property of transition is that they can form complexes, है ना? They can form coordinate bonds and they can form coordinate complexes, है ना? Coordinate compounds. So the actinoids, they have higher tendency to form complex. Lanthanides, they have generally lower tendency. So lower tendency to form complex and इसकी यहाँ होती है higher tendency. 6, they don't form oxoanion. Oxoanion amino 4 negative K2Cr2O7 2 negative C. These are oxoanion. Actinides, they can form oxoanions. They form oxoanion. Seventh में here only one metal, that is promethium. Only promethium is reducing agent. In actinides are reducing agents. 8, these are generally less basic and these are more basic. That means they can react very fastly and very quickly with acid. More basic. So the last topic that we have is the consequence of lanthanide contraction. ना उसी में ये वाला point भी आ जाएगा, basic strength वाला भी आ जाएगा, ठीक है। Copy this down. Raise your hand if you're done. Reducing agent. इसलिए reducing agent, RA is reducing agent. Right, next, consequence of lanthanide contraction. First consequence is similarity between second transition series, that is the 4D series, and third transition series, that is the 5D series. Okay. Similarity between the second transition series and the third transition. Similarity, first of all, uh, similar size, similar properties. And in detail, we have already seen this. अगर हम बात करें contraction की, then what do we have? Second year लाएंगे AC, then we have D जरा half. So between lanthanum and hafnium, we have all those elements. Starting this lanthanum is 57 and the hafnium is what, 72. So in between we have the 14 elements. In between what do we have? We have the 14 elements. And those 14 elements, in that the size is gradually decreasing and the 4F subshell is being filled, which has poor shielding, That is why when I compare the size of this 3D series, उसके बाद 4D series, and then we have 5D series, so gradually as we go down, the size should increase because the shell is increasing. But होता क्या है that as I go from titanium to zirconium, then obviously the size is increasing. But when I go from zirconium to hafnium, the shell is increasing, but the shielding is very poor. So when the shielding is poor, then the nucleus can easily attract the valence shell electron, can make the size even smaller. And that is why zirconium has almost equivalent size as that of hafnium. And size, and they have what? They are all metals, so they have tendency to lose electron. And if they lose electron, they will be having positive charge. So if you have anything which is of same size and both of them are having positive charge, so obviously they are going to behave very similarly, right? Because in reality, if you think about it, zirconium, if you think about zirconium in reality, then zirconium will be a certain sphere which has certain positive charge. That's it. And what will be hafnium? Hafnium will also be a sphere with certain positive charge, right? Both of these elements, zirconium and hafnium, both of these elements, they are having same positive charge and same size. Obviously, they are going to have same properties. Does it make sense? Yes or no? Correct, Maimuna and Shita, right? Zaina?
Yes.
And if they're having similar sizes, then they will be having similar also. Now, next is similarity between a similarity among lanthanides. So the lanthanide, they show very similar properties also because of the same thing that we have discussed here. उनमें size भी मतलब छोटा होते जाता है and almost very small changes in happening, and both of them will be having positive charge as they are mostly metals. That is why they have behave very similarly. इसका एक और consequence ये होता है due to similar chemical properties. It is difficult to separate them in pure state. Third is regarding the basic. ध्यान सुनिए यहाँ पे. As the size of cation decreases, covalent character increases. ठीक है. Now, if we are moving from lanthanum 3 positive to lutetium 3 positive, the size decreases because of lanthanum contraction. The size decreases and कोवलेंट कैरेक्टर इंक्रीज कर रहा है. इसका मतलब क्या होगा? आयनिक कैरेक्टर इज so we can directly say as we go from lanthanum to lutetium, then the size decreases, and due to that, ionic character also decreases. Ionic character also decreases. Now, when the ionic character is going to decrease, then it is going to make very difficult for the OH negative ion to break the OH negative ion. As the ion character decreases, it is difficult to lose the OH negative ion. अगर आपसे हम पूछें कि for example, if I have NaOH, then directly we have Na positive and OH negative, which is already dissociated. But if I talk about C2H5OH, that alcohol, so we have a covalent bonding, and this OH is not as acting is going to act as OH negative. So जितना ionic character ज़्यादा होगा, that much OH negative you can easily get, right? Because in ionic character, OH will be present as OH negative. But if there is more covalent character, then in that case, OH will not be present as OH negative. It will be difficult to lose the OH negative ions, and that is why we have written this. That is why we have written earlier also. Therefore, we can write basic strength decreases with increase in atomic number. Increase in atomic number. ठीक है? ठीक. Copy this down. Raise your hand once you're done. Rishita, I think we discussed to start chemical kinetics next, right?